Okay, guys, I hope everyone can hear me. So, welcome back. So here we are. What this week will be is the last week of lecture time, where I'm presenting slides and new material. But what we will do is starting next week. Hold on a second. There's a noise outside. Let me go close the window. Okay, so starting next week, what we'll do is we'll have presentations. Okay, so hopefully everyone's ready. So what I'll do is, in light of the fact that presentations start a week from today, what I'll do is, after we finish the logical data model discussion, hopefully that should be done in the first hour today, then I'll use the second hour to talk about the group project and what the expectations are there. Okay, so yeah, so that's what we'll do today. So let's go ahead and finish up our logical data model discussion. Why is this not coming up? Why is this not giving me my options I want? Huh. See if this works. Okay, so hopefully what you're seeing is the PowerPoint slide. Microsoft Teams, they must have made an update or something recently, because the options were different than normal. Okay, so we talked about the last thing we talked about was the many-to-many relationship types. If you remember what I did last week by showing on the whiteboard, was why we resolve this the way that we do. Why the problem is we can't just put a foreign key to the other table's primary key in one of the two tables involved in a many-to-many relationship. Why that does not work. That cannot solve the problem with continuing to have without having update anomalies be possible. All right. So what we do for a many-to-many relationship is we create what I call the table in the middle. Right. So we take we create a table, and its primary key is the combination of the two. It's the combination of the primary key from table 1 and the primary key from table 2. And so if there is a relationship, if there's a connection between those two. So the example that you saw on the whiteboard, the tablet version of what I did last week, was men and women and being friends. Like, this man is friends with this woman, right? And what we said was, if a friendship happens, if a linking happens, they just get a new row. They get a row in that middle table. And so if his primary key and her primary key, if those values show up together in a row in that intermediate table, in the middle table, then what happens is that represents a friendship between the two. So that represents a linking there. Okay, so that's how we do the many-to-many binary relationship type. We also, I don't think I mentioned this last week, the complex relationship types. It's similar. It's really similar to a many-to-many relationship, but the complex would be if of any more than one entity. So a 3-entity, 4-entity relationship that exists. Then what we can do is we can create a table, again, a table in the middle, and any row in that table represents a linking between all the tables involved in the relationship. In fact, one of you that I know of, one group that I know of, your group project actually, I didn't realize it until about our third or fourth conversation back and forth, but one of you has a relationship type like this, possibly. That is a possible resolution for how to design your system. And so you have this table in the middle that kind of, the table represents the relationship between all of these entities that are participating in the relationship. Now, remember, one thing I want to make clear, this middle table does not show up in a simple ER diagram. Okay? The middle table between the complex relationship types or between the many-to-many relationship type, that middle table does not show up in the ER diagram, but it needs to be present in the database itself. Okay, so that's one thing that I want to make sure that you're clear about, is that there's a difference between the ER diagram and the ER diagram and the actual database itself. Okay, all right, so let's move on a little bit. Okay, so back to our thing here. So another thing we had, so we've talked about so far, we talked about one-to-one relationships. We talked about one-to-many relationships. We've talked about many-to-many relationships. We've talked about these generalization things, how to handle the mandatory or and stuff like that. Let's see, what else? Where are you? Actually, funny, I don't see an example here in this diagram of what we're going to talk about next. That's interesting. Okay, so but let's talk about it. Actually, okay, telephone number was one that we had talked about, that if somebody has more than one telephone number. But the idea is the multi-valued attribute, and what that means is we have an attribute in the table, or sorry, in the entity, that can have more than one value for the same information. And what that means is, let's say, for example, I don't have it. Oh, here it is. Yeah, I have my phone. All right, I have my phone here, and if I pull up my contact list, I'll pull up mine. Okay, I'll pull up my information on my contact, and I don't know how well you can see this, but so I've got like all these phone numbers, and no, I just put all my phone numbers out there for everyone to see. But anyway, okay, so there's all these phone numbers that I have for me, right? My work phone number, my office phone number, my cell phone number. There's also a few other phone numbers that are saved in there that are actually old numbers that I don't have anymore. But the idea is that we might want to store more than one phone number for someone. Now, what we could do is we could create a telephone number 1 column and a telephone number 2 column and a telephone number 3 column. But that could get really problematic for a couple of reasons. One, what if someone joins the system and they have more phone numbers than we currently allow based on columns? Well, do we need to change the entire database for them? Do we need to change the entire database to add a new column so that we can store all 4 of their phone numbers? Do we need to tell them, nope, you can't have that many phone numbers, sorry? All right. What about, and this one is actually more likely because we can limit. I mean, we can say, hey, we're only going to store 3 phone numbers for somebody in this system. That's not entirely unreasonable. But the bigger problem is, what about we store 3 columns? Let's say we have 3 columns for phone numbers, 1, 2, 3. And the majority, the vast majority of the people in our system only have 1 phone number. Well, what does that mean? That means that there's going to be a lot of null values out there, right? A lot of wasted space, a lot of wasted processing. Because if you think about it, then too, anytime we want to gain, if we want to search for phone numbers with a certain area code, right? So like mine starts with 5. Mine is 531, I think. Yeah, but what I've heard is that the area code can be where you registered the phone or where you got the phone number or something like that, or what company, right? What company? Like I'm with Turkcell, and I've heard that like the first 3 numbers tell you who which company it is. Okay, and that's great. So let's say we want to search for all phone numbers from a certain company that start with a certain set of digits. Well, we've got to write a query that that searches column 1, searches column 2, searches column 3, right? And that can be a big problem. And so what would be nicer is if we could have, what would be cleaner is if we could have a single column that was phone number, right? And if in that one column we could store all the phone numbers for a person. Right? But the problem is that if we were to make that a single column in our customer table or our client table or whatever it is, then every time somebody adds a new phone number, we've got to add a new row for their information, right? That's a problem. Okay, so what we're going to do instead is for any multi-valued attribute, we're going to create a new table. Again, another new table. Right? We're going to have another table, and that table will have a couple of columns. Right? One of them will be the column of interest, the column of the attribute, so phone number. Right? Then the other column will be a foreign key to the primary key of the table that it's referencing. So like to our client table, to our student table, or to our employee table, whatever. Okay. And so what'll happen is the combination of the value and the primary key, the foreign key to the other column, that makes up our primary key. Okay. So that is a way that we can store. And the nice thing about this is that just means every time somebody wants to add a new phone number, we just add a new row in that table. And the only copy information is the primary key of the other table. So we're not copying other information, name, email address, birthday, whatever, all that other stuff. We're not copying all of that. We're not duplicating any of that. The only thing that we're doing, again, is we're copying the primary key only. Okay, the foreign key really, but the foreign key value that represents the primary key of the other table. Okay, all right. So that's how we would do that. Let's see. That would be like if telephone number. So what would happen is we would create a new table over here called telephone, assuming that telephone number is a multi-valued attribute. We would create a new table over here called telephone, and it would have the column telephone number and would have the column client number. And every time that a client wants to add a new telephone number for themselves, we just add a new row with their client number and that new telephone number they're trying to add. Okay. All right. So simple summary of how to do this. This is all stuff that we've talked about already. Okay. It's kind of like in a much more kind of table format here, much simple kind of quick reference. Now remember, one of the things that I said was that the output of this would not be another ER diagram. The output of this would be, the output of the logical design phase will be kind of a set of data dictionary, or the kind of a set of relations that we're going to create. Now notice the ER diagram was entirely visual. It was an entirely visual way of seeing kind of the design of the database. All right. So this is going to be much closer to an SQL format. So what we're going to do now is we're going to have something that's not SQL itself, but we could basically kind of use this to generate SQL statements from it. All right. So notice we have the relation name of what we want to have, some columns of what the attributes are for this relation. We're going to say what the primary key is, and we're going to say any foreign keys if they exist. Okay. Here, notice we also have some other things where we might have an alternate key named. Now, in SQL, we've talked about, you may say, wait a second, Hojam, I don't remember alternate key being something we did in SQL. And you're right, it's not. But what this does tell us is this tells us something else. This tells us that this column here, alternate key, has to be unique. And what we'll talk about in, we did talk about it in SQL, was we talked about the unique constraint, where we can put a constraint on a column to say this column has to be unique. And even though it's not the primary key, that when someone tries to put in the same information into that column on a new row, for if it's the same information that already exists, the same value that already exists in a previous row, all right, it'll say, oh, okay, good, Ur, I'm glad to hear that. So if they try to put in a new row that with the value in this column matches the same value as another column that already exists, it will reject that row from being inserted into the database. Okay, or if we're updating an existing row and it matches, then it will reject that update. Okay, so same thing. So again, so all of these things, right? We have the relation name, we have what primary keys are there, any foreign keys that might exist. We're also going to talk about this derived data, okay? Because there's different ways to do this derived data. In fact, I think that's, let me make sure it's in this section and not. Actually, I guess it's in the next section. Thought it was here. I guess it's in the physical design. I thought it was in the logical. I'm sorry. Okay. But we'll talk about this derived data that is information that it's a column that kind of goes with this. It kind of goes with this table, but it's really representing information that's based on something else. Okay. So notice, like in this example here, the lease for renting an apartment, we might ask for a deposit, right? And the deposit is going to be the amount of money that someone puts down to like hold on to that lease, to hold on to that property for themselves. Okay. And what we'll say is the value of the deposit should be whatever the rent of the property for rent is, times 2. So a deposit is going to be 2 months rent. Okay. Now we could store this information as a column in this table. That is one possibility, one option. The other way is we could say, you know what, we don't actually need this column to exist. We could just calculate it based on taking the property for rent at the time and multiplying it by 2. All right. We'll talk about the different ways to do that because there's a trade-off here. That if we calculate it at the time that we need that information, sometimes that's a good thing, sometimes that's not so good. If we store it as a column, that could be good, could be bad, based on certain other factors. Okay, there's a trade-off. It's not that one way is always better than the other. But we will have to make what I'll call a design decision. We will have to make a decision about how we're going to do this. And once we make that decision, we have to stick with it. Okay, we have to stick with it, or at some point down the road, if we decide this is not working, we need to go with the other way to do this, then we'll have to make changes to the database structures themselves. Okay, all right, so I really thought we had talked about this, but can't remember. Okay. All right. Okay. Normalization. So once we've kind of created all of our tables here, our relations, right? Created the general idea of some of the key parts, the primary key, foreign key, some of the other information here. Right? We can validate that using normalization. So we're going to make sure that to whatever level of normalization we need to be at, that our relations are actually normalized to that level. Okay. Make sure that, so if we're talking third normal form, let's just assume that, like for the group project here, we're talking third normal form. We make sure that in no relation is there, are there any partial dependencies? We make sure that in any relation, there is no transitive dependency. Okay. Okay. We also validate against user transactions. This is just making sure that the ways that we understand the user is planning to use our system, that the relations are connected in the way that makes the most sense. Okay. We'll also make sure that integrity constraints are represented. What's required data? So in other words, what can and cannot be null? What are some of the domain constraints? Are we going to put a constraint on birth date that it has to be in the past? Are we going to put a constraint on gender that that it has to be male or female? Stuff like that may be something that we'll consider putting domain constraints on. Multiplicity, entity integrity has to do with primary key. Every relation has to have a primary key defined. Referential integrity is every relationship between two entities represented in some way by a foreign key situation. So for example, in the one-to-many relationship, do we have a foreign key column on the many side of that relationship that points to the primary key of the one side? Right? And we make sure that we have all of those referential integrities, all the references done up well. So if we go back and look at this again, that would be stuff like this, where foreign key client number references client. Okay, so we know that is set up well so that we can have that. Okay. All right, so we talked about these referential integrity constraints, the foreign key, about making sure that what do we have this part defined on what happens on update, cascade, right? So on update, we want to cascade that. So if the staff number in the staff table changes, we want to change it here. On delete, set null. So what that means is if we delete the staff person from the staff table, we don't delete the supervisor. So there's right. If we delete the supervisor for a staff person, rather, so this is referencing the supervisor staff. If we delete the supervisor, we don't delete the staff person. Okay. Let me find a better one. Let me find a better example here. Property for rent. That'd be a better one with the staff. Okay. On update cascade, what that means is if the staff number for a person changes, their ID changes, but we still consider that they are the ones who are managing a property for rent. So we changed the staff number in the property for rent table to match the new staff number of that person. On delete, set null. What that means is that if we delete a staff person from a table, we don't delete all the property for rent that they've been managing, right? We set that column to null. What that means is that in the property for rent table too, the staff number will need to be able to be null. Okay. By comparison, so for example here on update cascade, if the property for rent number changes, we change that in the viewing table. On delete cascade, if we delete the property for rent from the table, we also delete it from the viewing table, right? Makes sense that we're not keeping track of people who viewed old properties that don't exist in our system anymore. Okay. All right. Some examples of the referential integrity constraints. We talked about that back when we talked about SQL, so I won't go into that anymore. Just like with the conceptual model, we take this model, we review it with the user, make sure that they are A-OK, that they are good with what we've developed. And then finally, an optional step we talked about, and I talked about briefly a while back, is to merge logical data models into one global model. This is if you are doing part of a system and some other team is in charge of some other part of the system. Okay. This is probably another thing that might be best done visually, so I may end up doing the tablet thing with you guys again on this. Okay, but basically what we're going to do is we're going to merge the logical models into a global model. We're going to validate that, again, and we're going to review that with users. All right, so we kind of got to go back through. So we basically reviewing our personal logical model with the user is kind of checking with the people who are in charge of our portion of the system. Okay, the reason why the merging part is optional is because we may be in charge of the whole system. Okay? We may not be in charge of only one part of the system. Okay, but when we go to merge, okay, we're going to check the names and contents of any entity's relations in both our model and in any other models that we're merging with. So again, an example that we might use is that if somebody were creating a model, creating a database for our university, one team might be in charge of the student portion, how the students are going to interact with the courses and the whatever. And somebody else might be in charge of the teachers, how the teachers are going to interact with the system. Well, both will probably have an entity called course or class, right? But how they're related and how they're connected may be different, right? So, but we're going to look at the names and contents, and we're going to see what matches and what doesn't match. We're going to review the names and contents of different relationships and foreign keys. We're going to merge them, okay? And what that means is that if we find two entities or two relationships, all right, sorry, relationships come second here, entities first. Any entities that seem to exist in both models. So let's say, for example, one team calls their entity course, and it represents courses that a university offers. And then another entity calls it class, because it's classes that you have to go to class. And yet another team that's working on some other part of the system calls it ders, because they use Turkish language. Right? Well, all three of those represent the same thing, right? They represent the same concept, a class of students who are learning, right? A classroom, that kind of thing, right? And so what we'll want to do is we'll want to merge those into one entity in our final model, because we don't want to have a course entity and a class entity and a ders entity. All right. What we want is to have one single entity that represents all three of these things. And we expect that some of the attributes in each of those entities are going to have some overlap. They'll all have a course code. They'll all have a course title. They may not be all those attributes may not be named the same thing. Right? But we need to merge those, and we need to take all of the overlapping ones and bring them together. We need to, any attributes that exist in one model but not in another for the same entity, we need to take those in, right? Let's say that two different teams working on the same system both have an employee table. One of them calls it the employee table, one of them calls it the staff table. One of them has salary because they're dealing with human resources stuff. The other one doesn't have salary. We still need salary in the final model because it was part of one of the starting models, right? Okay. All right, so we got to merge. So now we have all of our entities. Oh, step 4, we include without merging entities and relations unique. So if there's an entity, let's say one group has the student side, they have a student entity. The other group working with the teachers does not have a student entity. We still need to take that student entity and bring it into our final model, right? Because it existed as one of them, we're merging them together. So anything that exists in one but not the other has to come into our final model. All right. Now, step 5, we're merging relationships. So any relationships that exist in both. So if there's two entities that are in both models that we're merging, and there's a relationship between them, we need to merge them. Now, again, sometimes these things may not be exactly the same. One of them might be a one-to-many relationship with optional participation on one side. The other might be a one-to-many relationship with mandatory participation on both sides. Okay, so now we need to decide which one do we keep. Do we keep the optional? Do we keep the mandatory? It depends, and we need to talk it through and try to figure that out. Okay. Again, just as before, we include without merging any relationships that are unique. So if there's one model that has a relationship between two entities that does not exist, that relationship does not exist in any other model, we bring it in just as is. Okay. All right. So then we check for any missing entities. We check for it. So basically just checking again. Is this correct? Is this after we've merged it together? Have we accounted for everything? Have we gotten everything into place correctly? Okay. We can draw the global ER relation diagram. So now we have a relation diagram that we can draw for this and verify. Okay. Okay. Again, we validate using the user transactions. We review the global model with the user, and we end up with a final merged version that has all of our relations along with primary key, foreign key, right? Relations that represent our global model, and this could be our global relation diagram for the DREAMHOME system that we've been talking about. All right. Notice there's lots of new tables here because we weren't part of this originally. Okay. Remember this registration table? This represented way back when, if you can think way back when, it represented a three-way relationship between staff, branch, and client. Okay. Notice that in our final here global model, we don't have a relationship between staff and client. We don't have a relationship between branch and client. This registration table or relation represents the three-way relationship between staff, branch, and client. Okay. All right. And notice again too also this client viewing a property for rent was in our original ER diagram was just a simple many-to-many relationship between the client and the property for rent that represented them viewing a property. Okay. Now we have this viewing table that is between the two of them. Okay. All right. All right, so that concludes our discussion on the logical data model. Right? The logical database design. What we'll do is we'll go ahead and take a break now. So unless there's any questions, and then at 2:05 now, 2:15, we will come back and we'll do the group project discussion, and I'll let you know what to expect on that. Okay. All right, so we'll be back in 10 minutes, so 2:15. All right, see you guys then.